Hey guys, and welcome back to another episode of Physics Explained. Remember that you can always catch me on Facebook or Twitter at these @tags, and you can always check out the website www.physicsexplained. These episodes also go up on there, and they go up on the Facebook a couple of weeks after they get released on YouTube and the website. But if you want to know when I'm doing stuff, these are the best links to hit, and I usually get back to questions and stuff fairly quickly. And hit that subscribe button if you want to get notified of when I get videos out. Yep. So here we go, let's roll that music. Okay guys, so what are we looking at in today's episode? Well, today we are looking at different types of energy. Now I don't mean like energy resources such as solar, wind or nuclear power type thing. I mean the different types of energy that work in our universe. Now let's get a few things cleared up first. The conservation law of energy states that the total energy of an isolated system in a given frame of reference remains constant. Now, while that sounds very complicated, what it can mean is frame of reference could be our universe. So in that respect, we consider energy to be conserved over time within our universe, and directly that means that energy cannot be created or destroyed, it's merely transferred from one form to another. And as if by magic, a table appears. Don't worry, I will be going into all of these individually to make more sense of what they actually mean, but here is a fairly comprehensive list of all the different forms of energy that exist within our universe. Now, really there are only 7. These in brackets here are often referred to as forms of energy, but actually they're a consequence of something else. So let's start with the first one, kinetic energy. This is the simplest energy that there is. This is as a result of an object being in motion, and we know that an object is in motion when it's been applied an external force. So any object in motion has energy to make it move, and this energy is called kinetic energy. Next we move on to potential energy, and this is energy stored in an object by changing its position within a field. For example, if I pick up this pen, I've given it some potential energy by holding it at this height in a gravitational field. Now this also applies to electric, magnetic and gravitational fields. And so this potential energy is often broken down into electrical, magnetic and gravitational energies. But they're all a type of potential energy stored by moving an object within a field. So if you moved an electron within an electric field, you would give it some electric potential energy, for example. And kinetic and potential energy are sometimes referred to as mechanical energies because they're to do with the movement of an object. Now we move on to chemical energy. And this is the energy stored in chemical bonds within an atom. And this again is broken down into ionization, nuclear and chromodynamic, and this is just the difference between binding an electron, binding nucleons, which are protons and neutrons, or binding quarks, which are the things that make up protons and neutrons. But generally we refer to that as some form of chemical energy. It's to do with the bonds within atomic structures and the energy that they store. And finally, thermal energy. Now thermal energy is a weird one because it's actually not a thing. Thermal energy is a result of molecules within inside a substance or within an object or within a material or anything, even in the air, moving within a field and moving. So it's the sum of the potential and kinetic energies within the object or within the air or within a gas or within a liquid or in a table or whatever that give it some thermal energy and increase its temperature. So temperature is directly proportional to the potential and kinetic energies within inside whatever it is you're measuring the temperature of. The hotter an object gets, the faster the molecules move, and if you get it hot enough then the chemical bonds will break. That releases some energy, which again only increases the temperature of whatever it is, and that's how you melt liquids, melt solids into liquids, or evaporate liquids into gases. Just to quickly link in with our SI unit video that's earlier on in the series, we give energy this symbol, the capital J, and give it the unit joule. And this is after James Prescott Joule, who discovered that heat or thermal energy is the sum of mechanical energies, the kinetic and potential energies. Okay, so there you go, guys. That's all for this episode. That's all for me today. Remember that if you want to find me on other social medias, or if you want to go check out the website, these are the links. Both Facebook and Twitter are both at Physics Explained. Twitter's a little bit different the way it works. Twitter's a little bit different the way it works. It's at symbols. But yeah, the website www.physicsexplained.co.uk, and remember, you can always hit that subscribe button, and it should send you notifications every time I publish a video. Yeah, that's all for me. Thanks for watching.